This is part 2 of our lesson on solving exponential equations. So our instruction was to solve each of the following, and we are now on the example 4 to the power of x minus 18 times 2 to the power of x plus 32 equals 0. So our strategy that we're working on is writing things as powers of the same base. And I do notice that I have two powers. I have 4 to the power of x, and I have 2 to the power of x. I also have an 18, which is a coefficient, and a 32, which is just a constant. So I do notice when I look at the two powers that 4 and 2 do not have the same base. But I am going to see if I can write them with the same base. So 4 is a nice power of 2. It's actually 2 squared. So I'm going to rewrite this as 2 squared to the power of x minus 18 times 2 to the power of x. Now the 32 is a power of 2, but it's not going to be 2 to the power of x. There isn't going to be a variable there, so I'm just going to leave it as 32 for right now. Right? And the reason is that I know the exponent is not going to be an x, so it's not really going to help me here. Now 2 to the power of 2 to the power of x is the same as 2 to the power of 2x. And when you have a power on a power, you multiply the two exponents together. So whether I do 2 times x or x times 2, it doesn't really matter. So I'm going to rewrite this as 2 to the power of x to the power of 2. And the reason I did that is because I have another 2 to the power of x, and I think it will make it easier to do this question if I write both of them as 2 to the power of x's. So it's the same thing. 2 to the power of 2 to the power of x is 2 to the power of 2x. 2 to the power of x to the power of 2 is 2 to the power of 2x. Right? So when you're multiplying, it doesn't matter which one comes first. So I do now notice that I have 2 to the power of x and 2 to the power of x. So I also have a number and a coefficient. So this to me has 3 terms, which makes it a trinomial. Now this question is different from the previous question because this question had multiplication and division, and I could use exponent laws to simplify. This equation here has addition and subtraction. We do not have exponent laws for addition and subtraction, so I cannot use exponent laws to simplify. So what I am going to do instead is try to factor it. And in order to factor it, I'm going to try taking out the 2 to the power of x and put in a different letter like a. So if I take out the 2 to the power of x and put in a, I get a squared minus 18a plus 32 equals 0. And now it looks like a polynomial equation. So I'm ignoring the exponent part, and we're just focusing on our polynomial. So a squared minus 18a plus 32 equals 0 has 3 terms, which means I should be able to solve it by either factoring or the quadratic formula. So I think I'm going to try factoring. I do like factoring better than the quadratic formula, but it is preference. You always have the choice. So I'm looking for two numbers that multiply to 32 and add to negative 18. So things that make 32 would be 1 and 32. That does not make 18. 2 and 16. I could make an 18 out of a 2 and a 16. So I'm going to do negative 2a minus 16a plus 32, and that still equals 0. I'm going to group the first two and the last two together. The first pair has an a in common, and I get a take away 2. The second one, both divide by 16. I'm going to take negative 16, and I get a take away 2. And that still equals 0. So this factors to a minus 2 times a minus 16. And then that equals 0. So what we've done up to this point, we took our equation, we wanted to try to write them with the same base. So I said that 4 was 2 squared, and we ended up getting something that has two different 2 to the power of x's in it. And then I said, okay, well, I can't use exponent laws because we have subtraction and addition, and we do not have exponent laws for that. So instead I said, well, let's try taking out the exponential and putting in a variable. So we put in an a, we got a nice little polynomial equation, I factored, and this is where we're at. So from here you have two choices. We can either put the 2 to the x back in and have 2 to the x minus 2 times 2 to the x minus 16, and then take that equation and solve it. Or I can finish solving this and then put the 2 to the x in later. So I think I'm actually going to finish solving this first. Since these two things are being multiplied and we're getting a result of 0, it means one of them has to be a 0. So either a take away 2 equals 0 or a take away 16 equals 0. If I add 2 to both sides, I get a equals 2. If I add 16 to both sides, I get a equals 16. So I feel like I'm finished, but my original question did not have a's, it had x's. So I need to put the 2 to the power of x back in. And if I do that, I get 2 to the power of x equals 2, and 2 to the power of x equals 16. Now, we have talked about how to solve exponential equations, and you could use a log here, but the whole point of this is to talk about doing powers of the same base. So I'm going to show you how to do it with powers of the same base. 2 to the power of x equals 2. They already have the same base. What power is that 2 going to have? It would have a secret power of 1. So if 2 to the power of x equals 2 to the power of 1, they have the same base. So that means that x must equal 1. So my solution here is going to be that x equals 1. That's one of my answers. Now the other answer, I have 2 to the power of x equals 16. Now, can I express 16 as a power of 2? Yes, I can. 16 is 2 to the power of 4. Your power sheet is really helpful here. And then once I have the same base on both sides, that means 2 to the x equals 2 to the 4. So x is going to equal 4. So that's my other solution, is x equals 4. All right, so that's the end of our second example. You can join me in the next lesson to learn about solving using logs.